To correctly calculate fee growth inside a position, we'll need to consider three cases. Both the lower tick and the upper tick are not initialized, one of the tick is initialized, or both the ticks are initialized. In this video, we'll calculate fee growth inside when both of the ticks are not initialized. Let's first review what we found out so far. So we said that f out of I, we defined this to be the fee growth outside at tick I. And to initialize this, we initialized it to the current fee growth, f of g, if the current tick I of c is greater than or equal to this tick I. Otherwise, we initialize it to 0. And then whenever the current tick I of c crossed over this tick I, we updated f out of I to be f of g minus the previous f out of I. This is the algorithm that we'll be using to track f out of I. Next, we simplify the equation for fee inside. Fee inside, we define f of I lower and I upper to be fee inside the tick I lower and I upper. Then we found three equations for fee inside. We'll be using this equation when the current tick I of c is less than tick I lower. And we'll be using this equation if the current tick I of c is in between I lower and I upper. If the current tick I of c is greater than I upper, then we'll be using this equation. We'll be using all three of these equations in this video. Now we'll need one more equation to correctly calculate fee inside a position. Let's say that at time t0, a position was created. And then sometime later at time tk, we claim the fees. And we want to calculate what is the fee growth inside this position. We'll define f of 0 to be equal to f of I lower and I upper. So this is fee growth inside tick I lower and I upper at time t0. And likewise, we define fk to be f of I lower, I upper at time tk. Now to correctly calculate the fee growth inside the position, what we'll need to do is take fk minus f0. By using this equation, we'll be able to correctly calculate the fee growth inside the position, regardless of how the position was initialized, whether both the ticks were not initialized, or either one of them was initialized, or both of them were initialized. So for the last part of this video, we'll use this equation to calculate fee growth inside for the case when both I lower and I upper are not initialized. So let's calculate fk minus f0 when both ticks I lower and I upper are not initialized. Now there are three cases to consider. When the current tick I of c is lower than I lower, when the current tick I of c is in between I lower and I upper, and the last case when the current tick I of c is greater than I upper. We'll start with the first case as when the current tick I of c is less than I lower. So when the current tick I of c is less than I lower, let's imagine this case. So here we have tick I lower and here we have tick I upper. Both of these ticks are not initialized. Let's say that at time t0, we initialize this position between I lower and I upper. And at this point, the fee growth is over here, fg0. Let's also say that at some time later, the fee growth crossed over tick I lower. This is at fg1. And then at time t2, let's say that fee growth is somewhere over here, fg2. Now in this case, let's calculate fk minus f0. Again, remember that this represents the fee growth inside these two ticks, il and iu. Looking at this graph, we expect the fee growth inside to be the difference of the height, fg2 minus fg1. So when we calculate this equation, we expect the fee growth inside to be equal to fg2 minus fg1. So let's start out by calculating f0. f0 is the fee growth inside il minus iu at time t0. So to calculate f0, we'll use the equation that we listed above. And again, remember that the current tick I of c is less than I lower. So scrolling back up, when the current tick I of c is less than I lower, we'll need to use this equation. So going back down, f0 is equal to f out of I lower minus f out of I upper. And what are these equal to? Well, since f out of I lower is initialized to be 0, and f out of I upper is also initialized to be 0, this will be equal to 0 minus 0. In other words, f out is equal to 0. Let's also do the same for f of 2, the fee growth inside at time t2. At time t2, we have the current fee growth over here, and this is in between the tick I lower and I upper. So scrolling back up, the equation that we'll need to apply is this second equation. Going back down, F2 is equal to FG2 minus F out of I lower minus F out of I upper. FG2 is equal to FG2. How about F out of I lower? Well, we know that F out of I lower was initialized to 0, and then at time t1, it crossed over tick I lower. So what we need to do is apply this algorithm to update F out of I lower since it crossed over tick I lower. So going back down, F out of I lower will now be equal to FG1 minus 0. Since F out of I lower previously was equal to 0, at time t1 it crossed over, so we'll need to apply the algorithm to update F out of I lower. Okay, how about F out of I upper? Well, since nothing has changed, this is still equal to 0. Okay, and we're now ready to calculate F2 minus F0. And this will give us the fee growth inside IL and IU. F2 minus F0. If we simplify F2, we can see that this is equal to FG2 minus FG1. So the first part is equal to FG2 minus FG1. And how about the second part? F0. Well, F0 is equal to 0. So F2 minus F0 is simply equal to FG2 minus FG1. And if we take a look at this graph, visually we can see that the fee growth inside IL and IU is equal to FG2 minus FG1. And our equation stays the same. Next, let's calculate fee growth inside when the current tick IOC is in between I lower and I upper. Here we have a graph, and let's say that I lower, we represent this as IL, and I upper, we represent this as IU. And again, both of these ticks are not initialized. Let's say that when we initialize this position, the fee growth is somewhere over here at f of g0. So when we initialize this position, we'll need to apply this rule over here. We'll need to set f out of I lower to be equal to the current fee growth, since I lower is less than or equal to the current tick IC. So going back down, over here we'll need to initialize f out of I lower to be the fee growth, fg0. And f out of I upper, we'll initialize this to be equal to 0. Let's say at time t1, the current tick crosses over the upper tick, and then at time t2, we want to calculate fee growth inside I lower and I upper. And looking from this graph, we expect this to be equal to f of g1 minus f of g0. To begin with, let's calculate f of 0. This will be the fee growth inside at time t0. Okay, so we'll need to apply one of the three equations that we listed over here. Now this case is the current tick IOC in between tick I lower and I upper. So we'll need to apply this equation. So going back down, f0 is equal to this equation. The first part, f of g0 is equal to f of g0. The second part, f out of I lower, we initialize this to be f of g0. In the third part, f out of I upper, we initialize this to be 0. F of 0 is equal to f of g0 minus f of g0 minus 0, or simply this is equal to 0. How about f of 2? Fee growth inside at time t2. At time t2, we have the current tick above tick I upper. So which equation do we need to apply? Well, in this case, we'll need to apply this equation. Going back down. Okay, let's start with f out of I upper. At time t1, the fee growth crossed over I upper, so we'll need to apply the update algorithm, the one over here. Before f out of I upper was equal to 0, and then when it crossed over, we'll need to update it by f of g minus f out of I. So going back down, at time t1, we'll need to do f of g1 minus the previous f out of I upper. This will be equal to f of g1 minus 0, or simply f of g1. Okay, how about f out of I lower? Well, this is equal to f of g0. And you can see this over here that it was initialized to f of g0, and it has not changed since. How about f2 minus f0? Well, it will simply be equal to fg1 minus fg0. f2 is equal to this fg1 minus fg0, and f0 is simply equal to 0. Okay, so this is the equation for fee growth inside in this situation. fg1 minus fg0. And we can verify visually that fee growth inside is fg1 minus fg0, which is equal to this equation. The last case that we'll consider is when the current tick ILC is greater than tick I upper. Imagine the case we have I lower and I upper, and both of these ticks are not initialized. When we create a position, the fee growth will be over here, above both of the ticks. And let's say at time t1, the current tick crossed below tick I upper, and then at time t2, we have the current tick in between I lower and I upper. And what we're going to do is calculate the fee growth inside at time t2, when the current tick is in between tick I lower and I upper. Again, we'll start by calculating f of 0. So again, remember that at time t0, we have the current tick IOC over here, which is above both I lower and I upper. So going back up, the equation that we'll need to use is this equation. F out of I upper minus F out of I lower. Okay, so what is F out of I upper equal to? Well, when we initialize this position, we note that the current tick is above both IL and IU. So this means that we'll need to initialize F out of I lower to be the fee growth, FG0, and likewise, we'll need to initialize F out of I upper to be the fee growth, FG0. So F out of I upper will be equal to FG0. And likewise, F out of I lower will be equal to FG0. So F0 will be equal to 0. Okay, how about F2? At time t2, we have the current tick over here in between tick lower and tick upper. So which equation do we need to use? Going back up, the equation that we will need to use is this second form. So this is equal to Fg2 is equal to Fg2. How about F out of I lower? Previously, F out of I lower was initialized to be F of G0. This has not changed and it is still equal to Fg0. Okay, how about F out of I upper? Well, notice that F out of I upper at time t1, the tick crossed below tick I upper. So we'll need to apply the update algorithm. At time 1, fee growth was equal to Fg1, and then before that, it was equal to Fg0. So once we apply the update algorithm to tick I upper, we get that the current F out of I upper is equal to F of G1 minus F of G0. Okay, we can see that we have a minus F of G0 here, and then a minus Fg0 here. These two cancel out, and we're left with Fg2 minus Fg1. And lastly, F2 minus F0. F0 is equal to 0, and F2 is equal to Fg2 minus Fg1. So F2 minus F0 is equal to Fg2 minus Fg1. Okay, does this equation look correct? Well, looking at this graph, we can see here that the fee growth inside must be equal to the difference of Fg2 and Fg1. So this is the fee growth inside when the two ticks were initialized below the current tick. To summarize, we verified that this equation correctly calculates the fee growth inside when both of the ticks are not initialized. In the next two videos, we'll do something similar. We'll calculate fee growth inside using this equation when one of the tick is initialized, and in another video, we'll calculate the fee growth inside when both of the ticks are initialized.